let's go through this example, and I think it will be a lot easier to understand what I've just said. So pretend you want to do a study, an experiment, where you're asking the question, is one brand of toothpaste better than another brand of toothpaste? Because let's face it, when you go to the store and you want to buy, let's say, Colgate can cost 4 times the price of, let's say, AIM or Aquafresh. So you could pay $1 a tube for AIM or Aquafresh, and Colgate you're going to be paying over $4. Well, is there really a difference, or are you just, being duped, I guess? And so you decide that you're going to test different brands of toothpaste, and you're going to use kindergarten-aged children. The reason why you're using kindergarten-aged children is because they have very thin enamel, and they eat a lot of sugar, so they're perfect for this study. Right? Now, what are some possible extraneous variables in the study? So our independent variable is brand of toothpaste. And let's just pretend that we're going to compare, I think it's Crest and Colgate. Okay, so those are the two different brands, T for two. So we only have 2 groups here, Crest and Colgate. Now, that's the independent variable. What is the dependent variable? Number of new cavities, right? So brand of toothpaste could have an effect on number of new cavities. So what are some other variables that could influence the development of cavities, right? So you might think, well, what about the type of toothbrush? Whether they used an electric or a manual toothbrush. Or maybe it's whether the bristles are medium or soft. I don't think you can get hard bristles anymore. So you can buy a soft bristled toothbrush or medium. Maybe that makes a difference. What about how much sugar they consume on a daily basis? How about how long they brush for? Because you're supposed to brush for 2 minutes. So maybe some kids are brushing for 2 minutes and others are brushing for 10 seconds. Or we could just look at their technique. When my kids were growing up, I was always after them because they would just stick a toothbrush in their mouth and chew on it. And I'm like, no, that is not going to work. All right. So there's lots of extraneous variables here that could determine the outcome on the dependent variable, right? It could affect the outcome of whether, you get a lot of cavities or very few cavities. So we have to pick just one. So let's just pick brushing frequency. So how many times a day they brush. So this technique is done before you actually start your experiment, right? Matching or pairing. You do this before you actually start. So let's just say we have 10 kids in the study. When in real life, this would not be anywhere sufficient, but this is just an example. So you find out that child number 1 brushes twice a day. So now what you have to do is look at the other children and find another child that brushes twice a day. And the first one we come across is child number 6. So what you're going to do is you're going to pair child number 1 with child number 6 because they both brush twice a day. So you see how they are, in this case, they're identical on the extraneous variable. They're not just close, they're identical. Okay, so once you've paired them, then you randomly assign one to the Colgate group and one to the AIM group. Oh, I said Crest before. Oops, it's AIM. Okay, so one goes here, one goes there, and that's just random, who goes in which group. Then you look at the next child. This child brushes 4 times a day. So now you've got to find another child who brushes 4 times a day, and that happens to be child number 8. So child number 2 gets paired with child 8, and then what you do is you randomly split them up so that one goes in the Colgate group and the other goes to the AIM group. And you're going to keep doing this. You're going to pair split, pair split, pair split. And then if you've done this correctly, If we were to look at the mean number of times children brush in the Colgate group, that should be approximately the same as the mean in the AIM group. So again, these are not means of your dependent variable. These are means of the extraneous variable. This is the mean brushing frequency. And we can see that it's identical for these two conditions. Now, they won't always be identical. What if you had a child who brushes 7 times a day? Well, maybe you're not going to have another child that brushes 7 times a day. Maybe you're going to have one who brushes 6 times a day. So don't expect that these means here will always be equal. They just need to be statistically, these two means should be not significantly different. All right, so these should be statistically equal. And that occurs because you made sure that they were equal by the pair and split method. There's no way now that brushing frequency can become a confound. Remember the definition of a confound. It's an extraneous variable that is systematically different for the levels of your independent variable. Well, here, they're identical. They're not different at all. So if you do see a difference in the number of cavities between Colgate and AIM, you can now say with confidence, brushing frequency had nothing to do with it. All right, so you've ruled out the confound. Now, by using this technique, you can use a dependent t-test. Now, you hopefully recall that normally when we think of a dependent t-test, we think of the people in group 1 being the same set of people as in group 2. Peter, Paul, and Mary, Peter, Paul, and Mary. Well, these are different children, right? The children in the Colgate group are different from the AIM group. But you could argue, well, yeah, they're different people, but they are identical on one or more variables, extraneous variables that matter. So because they are the same on one or more extraneous variables that matter, we're going to treat them as if they're the same people. Now, somebody might want to know, can we match on more than just one variable? Like here we just matched on brushing frequency. What if we wanted to match on how much time they spend brushing? All right, so the duration of brushing. Well, you can do that, but you're going to have a bit more difficult time trying to find pairs, right? Trying to find matches. Imagine that you want to match on 6 variables. So your first child brushes 4 times a day, 30 seconds each time, with an electric toothbrush, who consumes on average 80 grams of sugar a day and has a thin enamel density. Now you've got to try and find that person's twin, in essence. Somebody who matches on all 5 of those variables. You see how it gets increasingly difficult? So we almost never match on more than 2 variables. It just becomes really hard.